Okay, hello everyone. I welcomes to all once again in our lecture series on special integrals, and we are discussing gamma function. In our last 4 to 5 classes, we have been discussed other forms of gamma function. 4 forms we have been discussed. Then we have been discussed properties of gamma function. Here we have been proved that gamma half equal to root pi. Then we evaluated gamma function having positive and negative fractions. We drawn this graph. Then we have been discussed some important numerical on gamma function. In our last class, we have been discussed 6 numericals based upon gamma function. Here, up to this much we have been discussed. In our today class, we are going to discuss some other numericals based upon gamma function, different type of numericals. Okay, so this is your question number 7th. What we are going to discuss today. Okay, 7th. That prove that gamma n into gamma 1 minus n equal to pi by sine n pi. Okay, this is a very important question. Based upon this question or this value pi by sine n pi, many numericals asked in your exams. So this expression is most important that you have to remember. Sometimes you can get this question itself, that you have to prove this one, gamma n into gamma 1 minus n equal to pi by sine n pi, for 3 to 4 marks. So let us start to prove it. Okay, proof. This question will be proved with the help of Wijkstra's formula. Okay, so from first I'm going to write from Wijkstra's formula. We know from Wijkstra's formula. Wijkstra's formula. Okay, Wijkstra's formula. We know that gamma 1 by n or gamma n already we have been proved. Okay, gamma n equal to this much already we have been proved. Here you can see this much 1 by n or gamma n equal to 1 by n e to the power minus n nu product summation k equal to 1 to infinity into 1 plus n by k to the power minus 1 into e to the n by k. Same thing I am going to write over there. Okay, 1 by n into e to the power minus n nu product summation k equal to 1 to infinity of 1 plus n by k to the power minus 1 into e to the n by k. Okay, that implies if gamma n will be this much, then gamma minus n will be how much? Here instead of n we have to substitute minus n only. Okay, so this will be 1 by minus n into e to the power, here minus n is there, so it will be plus n, minus of minus plus e to the power plus n nu k equal to 1 to infinity. This is the product summation of 1 minus n by k to the power minus 1 into e to the power minus n by k. Let this is your equation number 1 and this is your equation number 2. Now multiply these two equations. Now multiply equation number 1 and 2, we get what we can get. That implies here gamma n into gamma minus n will be equal to, here you can see 1 by n into minus 1 by n, so it will be minus 1 by n square. Okay, and here you can see e to the power minus n nu and e to the plus n nu, so e to the 0, e to the 0 means 1. Then here product summation from k to 1, here 1 plus a 1 minus a, so it will be here a plus b into a minus b formula we can apply. Okay, so it will be a square minus b square, right? I suggest don't be confused here. See, तुम सोच रहे होगे ये तो इसका पावर तो माइनस 1 है तो ये कैसे a स्क्वायर माइनस b स्क्वायर हो जाएगा, तो मैं यहाँ पे दिखाता हूँ। Here you can see. Suppose we have a plus b to the power minus 1, a minus b to the power minus 1. So it can be written as 1 by a plus b into 1 by a minus b. So this can be written as 1 by a square minus b square, which will be nothing but a square minus b square to the power minus 1. Same thing I have to apply for the product of these two terms. So if I will multiply this one plus n by k to the power minus 1 into 1 minus n by k to the power minus 1, it will be 1 minus n square by k square to the power minus 1, right? This is your k. Into here e to the power n by k plus e to the minus n by k. So when it will be multiply, then the power will be add up, so e to the power 0 means 1. So we found this much. Let this is your equation number 3. Gamma n into gamma minus n, we found this much, right? Now we are going to consider inner product formula of sin x. Okay, now consider inner product formula of sin x by x. Sin x by x. What will the value? The value of this sin x by x is nothing but, here I am going to write, by considering inner product of sin x by x is nothing but equal to how much? Infinite product starts from n equal to 1 to infinite. So here k is there, no? So it will be better that if we are going to consider k equal to 1 to infinity, k equal to 1 to infinite, 1 minus x square by pi square n square. Okay, this expression, that means sin x by x equal to this much, which is a very much important expression. May it will be required for some other numerical in your future. Okay, so to prove our main question that gamma n into gamma 1 minus n equal to pi by sin n pi, we have to use this one. Okay, sin x by x equal to this much, right? See, for this proof, for this question particularly, this proof sin x by x equal to this much is not required. Direct we have to use this expression, but here I am going to prove this one. Then after we are going to go for our work. That means we have to prove this one. Okay, first here I am going to prove this one, sin x by x, or the so-called inner product formula of sin x by x is equal to this much. How it is? To prove this one, sin x by x equal to this much, consider a simple polynomial having highest power is 2, suppose. That means if we are going to consider a in general, a polynomial ax square plus bx plus c equal to 0, having highest power is c, sorry, highest power is your 2, then this polynomial can be written as, how many roots we can get for this polynomial? So it has 2 roots. So it has 2 roots. Okay, 2 roots. So suppose one root is your x1 and another one is your x2. Then the above polynomial can be written the above, if these are x1 and x2 are 2 roots, then above polynomial can be written as a into x minus x1 into x minus x2 equal to 0, right? Now consider another polynomial. Consider a polynomial whose highest power is infinite. That is, here I consider a polynomial like this: a naught a1 x plus a2 x square plus a3 x to the power 3 and so on. So this is a polynomial whose highest power is your infinite, right? So hence this polynomial can be written by infinite number of multiplication terms. That means some constant, I'm going to write some constant c into x minus x1 into x minus x2 into x minus x3 up to so on. Because if we consider a polynomial having highest power is 2, so obviously this polynomial has two roots, so this polynomial can be written as like this. Likewise, a polynomial whose highest power is infinite, we can get infinite number of roots. Infinite number of roots. If it is so, then this polynomial can be written as infinite number of products by considering the infinite number of roots. So here x1, x2, x3 up to here x1, x2, x3 up to x infinite are the infinite number of roots. So this polynomial can be represented like this. Now we are going to consider sin x. The expansion of sin x, or the so-called Taylor series of sin x about x equal to 0. It is nothing but like this: plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial plus so on. It will be continue up to the power will be infinite, or we can write in general as n equal to 0 to infinity minus 1 to the power n divided by 2n plus 1 into x to the power 2n plus 1. So here you can see, for this polynomial the highest power is infinite, so n is moves from 0 to infinity. So here x to the power 2n plus 1 means x to the power infinite. So this polynomial sin x expansion is also a polynomial. This sin x series expansion is itself a polynomial, yes or no? It is itself a polynomial, and this polynomial has highest power is infinite, or we can say this polynomial has infinite number of roots. Hence, as we discussed previously, hence this sin x can be written as as product of infinite terms. That implies sin x can be written as c into x minus x1 into x minus x2 into x minus x3 up to so on. And here I'm going to write perfectly. Here x1 and x2 up to so on, or up to infinite, we can say, are the roots. Here x1, x2, x3 and so on are the roots. Okay. Now consider this sin x in polynomial format. Polynomial format means sin x equal to 0. That means this one, sin x represented as infinite product, or infinite number of terms multiplied with each other. If I am going to write equal to 0, then it will be called as polynomial like this one. Okay, here this is your polynomial having highest power is 2, and this can be written as product of two terms. Here sin x, this one is a infinite, highest power is a infinite, that means infinite number of roots we can get, and the sin x can be represented by product of infinite terms. If it will equal to 0, then it is nothing but your one polynomial. So if I am going to consider sin x equal to 0, that implies x equal to 0. Okay, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi and so on. Okay, or I can write in general x is nothing but k pi, where k equal to 0 plus or minus 1, plus or minus 2, plus or minus 3, and so on and so on, right? Right. Now that implies that implies sin x sin x will be written as here, this one, or this polynomial c into x minus x1 x minus x2 up to uh, and so on will be equal to 0, this polynomial. That means sin x equal to c into x minus first root is your 0, so it is x minus 0, then x minus pi, another root is your plus pi. Here this one, here if I'm going to consider this one, then from this I can get plus pi and minus pi. So if I'll be consider plus pi, then it will be x minus pi. If I'll consider minus pi, then it will be x plus pi. Then by considering plus or minus 2, we can get again two roots. That means x minus 2 pi into x plus 2 pi, right? Then x minus 3 pi into x plus 3 pi, and so on, right? Or this can be written as, that implies in summation format, what we can write, that implies sin x will be equal to c, here x minus 0 means x product summation starts from k equal to 1 to infinite x square minus k square pi square. Why I have been written this one? Here you can see x minus pi into x plus pi, this will be x square minus pi square. Here if I will multiply these two terms, it will be x square minus 2 square pi square. By multiplying these two terms, we can find x square minus 3 square k square. So in general, we can write this one x square minus k square pi square, right? Now that implies here x is there, x taken this side, it will be sin x by x will be equal to c product summation starts from k equal to 1 to infinite whole into x square minus k square pi square, right? But we know that for x tends to 0, sin x by x equal to 1. Okay, now we are going to apply this condition on the above equation. What we can find, first we have to write, that implies limit x tends to 0, sin x by x. Likewise, I have to apply limit x tends to 0 on the right hand side of this equation. What we can find, c limit x tends to 0, product summation k equal to 1 to infinite x square minus k square pi square, right? That implies this value is your 1 is equal to c, and if I will put limit x tends to 0, then here if I will put x equal to 0, then this value will be 0. So we can get product summation k equal to 1 to infinite minus k square pi square. That implies 1 by c will be equal to product summation k equal to 1 to infinite minus k square pi square. That implies c we found here, product summation k equal to 1 to infinite 1 by or minus 1 by k square pi square. So here we found c value, right? Now it will be better that we have to put a equation. Let this is equation number b, and this is your equation number a. This one sin x by x is your equation number a. Now we have to put uh, b value, equation number b, that means c value in equation number a. What we can get here, if I put, then what we can get, sin x by x will be equal to, here both the summations are equal, so I can write summation, product summation is infinite product or product summation. We can say k equal to 1 to infinite minus 1 by k square pi square whole into uh, x square minus k square pi square, right? That implies sin x by x will be equal to product or infinite product that starts from k equal to 1 to infinite. If I'll be multiply this one with this term and this term, we can found here this will be 1 once plus आ जाएगा वो 1, this term will be minus x square by k square pi square, right? k square pi square. Let this is your equation number c. इसको c दे के रखो, शायद हम here you can see. Now here you can see we consider here I consider this one k equal to 1 to infinite, k equal to 1 to infinite. So this will be k square. Mistakenly I written this one. This will be k square pi square k square. Okay. So here I have been proved the same that sin x by x equal to k equal to 1 to infinite 1 minus x square by k square pi square, right? So this much is not required for this proof. If I am going to consider question number 7, this much from here to here is not required. Here from this only you have to write this much is enough. Here I proved for. Now here you can see sin x by x, we found this one and here I proved also, right? If instead of x I am going to put n pi, then the equation number 4 will be if we put x equal to n pi, then equation number 4 will be, see here I am again I'm going to tell to you that this this proof is not required for this question. For question number 7, this proof, the infinite product of sin x by x is not required. Okay, so what I proved you can write in a note, may it will be required for some other numerical. Okay. Now here you can see if we put x equal to n pi, the equation number 4 will be what we can write, uh, sin n pi by n pi is equal to product summation k equal to 1 to infinite 1 minus, so instead of x if I will put n pi, so it will be n square pi square by k square pi square, so it will be n square by k square, right? N square by k square. Let this is our equation number 5, right? Now if I consider n pi by sin n pi, just I altered the numerator to denominator, denominator to numerator, then it can be written as like this, k equal to 1 to infinite 1 minus n square by k square to the power minus 1. Let this is your equation number 6. Okay. Now compare equation number 6 and 3. Here in equation number 6 we have n pi by sin n pi equal to this much. Here you can see product summation k equal to 1 to infinite 1 minus n square by k square to the power minus 1. If I am going to consider equation number 3, the left hand side is your gamma n into gamma minus n equal to minus 1 by n square into k equal to 1 to infinite into 1 minus n square by k square minus 1. Okay. So here from equation number 6, this value is nothing but n pi by sin n pi. If I am going to substitute in equation number 3, then what I am going to get, just write substitute equation number 6 in equation number 3, then we can get substitute equation 6 in 3, we get what we can get. Here you can see this much, gamma n into gamma n minus 1 equal to minus 1 by n square into this much. That implies gamma n into gamma minus n equal to minus 1 by n square into n pi by sine n pi, right? Okay, so that implies, here you can see, here n got cancelled, here 1n, here 1n got cancelled, and n minus n will be multiplied with this one. So I can write gamma n into minus n into gamma minus n will be equal to pi by sine n pi, right? Now here this minus n gamma minus n can be written as gamma 1 minus n, 1 minus n. Here minus n into gamma minus n is nothing but gamma 1 minus n, which will be equal to pi by sine n pi, sine n pi. So here you can see gamma 1 minus n, how it is minus n into gamma minus n. So this one can be written as gamma minus n plus 1. Gamma 1 minus n can be written as gamma minus n plus 1. So this will be nothing but minus 1 gamma minus 1 by using first property. First property. Okay, that is nothing but gamma n minus 1 equal to n gamma n. So here gamma minus n plus 1 will be equal to minus n gamma minus n. Okay, so same thing I have been written over here. Okay, so in this way we have been proved this one. This is most important question for your exam. If it will asked in your exam, no, it will asked for 4 mark question. Gamma n into gamma 1 minus n equal to pi by sine n pi. Now based upon this one, based upon this expression, we are going to solve a simple numerical. Here question number 8. Here question number 8 is your find the value of gamma 1 by 4 into gamma 3 by 4. This question will be solved by using this expression, gamma n into gamma 1 minus n equal to pi by sine n pi. Direct we have to write that we know that gamma n into gamma 1 minus n equal to pi by sine n pi. So here in your question it has been given that gamma 1 by 4 into gamma 3 by 4. Okay, this can be written as gamma 1 by 4 into gamma 1 minus 1 by 4. 1 minus 1 by 4 is nothing but 3 by 4. So this will be directly written as pi by sine. Here n is nothing but 1 by 4. So it will be 1 by 4 into pi, which will be equal to pi by sine pi by 4. Directly you have to write sine pi by 4 is nothing but 1 by root 2. 1 by here 1 by root 2, and answer finally we can get root 2 pi. This is your answer simply. And this question also very important question. 2 marks you can found in your exam always. Find value of this one. Okay, now we are going to go for our next question, question number 9. In question number 9 it has been given that we have to prove 1 into 3 into 5 up to 2m minus 1 equal to 2 to the power m gamma m plus 1 by 2 by root pi. Okay, let us start to prove it. So to prove it, we have to consider the first property of the gamma function. First, we are going to consider first property of gamma function, that is gamma n plus 1 equal to n gamma n. Hence gamma, suppose we are going to consider m plus 1 by 2. This m plus 1 by 2 also can be written as like this: m minus 1 by 2 plus 1, right? This can be written as, here minus 1 by 2 plus 1 is nothing but plus half. So if I'm going to use first property on this, then it will be m minus 1 by 2 gamma m minus 1 by 2, right? Again, gamma m minus 2, what we can write? Here you can see that implies uh, gamma m plus 2 will be equal to, here, m minus 1 by 2. This gamma m minus 1 by 2 also can be written as like this: gamma m minus 3 by 2 plus 1, because 3 by 2 plus 1 is nothing but 1 by 2, right? Minus 3 by 2 plus 1, so it will be obviously minus 1 by 2, right? So here this minus 1 by 2 can be written as minus 3 by 2 plus 1, right? Okay, again that implies, again this can be written as m minus 1 by 2, and here again I am going to apply first property upon this, then it will be written as m minus 3 by 2, then gamma m minus 3 by 2. Again, this m minus 3 by 2 can be written as m minus 5 by 2 plus 1, because minus 5 by 2 plus 1 is nothing but minus 3 by 2. So here gamma m plus 1 by 2 will be equal to m minus 1 by 2 into this one, into m minus 3 by 2. Again, m minus gamma m minus 3 by 2 can be written as m minus 5 by 2 plus 1, right? That implies this will be gamma m plus 1 by 2 will be written as m minus 1 by 2 into m minus 3 by 2 into m minus 5 by 2 into gamma m minus 5 by 2. So here m is your integer. I'm going to write here in the question. Here m is integer. Okay, if it is so, then इसका जो last term कितना आएगा? If I am going to consider any arbitrary m, then what will be the last term? To verify, you just consider m is one something value. Suppose m equal to 5. You just consider m equal to 5. Let to verify only. Okay, no need to write in the exam this one. Let if I am going to consider m equal to 5, then here m plus 1 by 2 or 5 plus 1 by 2 can be written as 5 minus 1 by 2, which will be nothing but your 9 by 2. Then 5 minus 3 by 2. 5 minus 3 by 2 will be equal to 7 by 2. Then 5 minus 5 by 2 will be equal to 5 by 2. Then 5 minus 7 by 2. 5 minus 7 by 2 will be equal to 3 by 2. Okay. Then 5 minus 9 by 2. 5 minus 9 by 2 will be half. Okay. Then gamma 5 minus 9 by 2 will become 5. My gamma 5 minus 9 by 2 is nothing but gamma half. So whatever may be the m value we are going to consider, the last two terms are 1 by 2 into gamma 1 by 2. Okay, so here the equation, the above equation, this one, what we can write, that implies, see, this much I have been considered for you that you have to easily understand. This much no need to write in your exam. Okay, so direct this from this step to this step. That implies what you have to write, gamma in general, gamma 1 m plus 1 by 2 will be equal to m minus 1 by 2 into m minus 3 by 2 into m minus 5 by 2. ये ऐसे चलता जाएगा, it will be continue, but the last term always, last two terms always 1 by 2 gamma 1 by 2, right? Okay, that implies, that implies gamma m plus 1 by 2. This is also one of the most important question. Important question means 5 mark 6 mark question. Uh, okay, you just practice it well. So this can be written as 2m minus 1 by 2 into, this will be 2m minus 3 by 2 into 2m minus 5 by 2, and so on. The last two terms, one term into half, and gamma half we know that root pi, right? And next, that implies gamma m plus 1 by 2, it can be written as, here you can see, 2m minus 1 into 2m minus 3 into 2m minus 5 up to root pi, and the denominators, the denominator is your 2 into 2 into 2. So how many 2s we are going to consider? Here you can see, whenever we consider m equal to 5, here how many 2s? 1 2 3 4 5. So obviously for m, if m equal to 5, there are 5 2s in the denominators, in the denominator. So here in general for m, it will be m number of 2s are going to be multiplied. For that I can write 2 to the power m. Okay, okay, so that implies, that implies I can write that gamma m plus 1 by 2, gamma m plus 1 by 2 into 2 to the power m will be equal to, here you can see, 2 to the power m, sorry, 2m minus 1 into 2m minus 3 into 2m minus 5 up to, up to up to what term we are going to get? The last term will be 1, last term will be 1, and before last term we can get 3, then before that we can get 5. How it is I am going to consider here, we considered this one, no? This example here we can also found the same, 5 into 3 into 1 whole into root pi, whole into root pi. This will be 5 into 3 into 1 whole into root pi. How it is I am going to show you with an example. You just see. Here you can see, here in this expression, if I am going to consider the numerator terms, numerator terms will be written as 9 into 7 into 5 into 3 into 1 into root pi divided by 2 to the power 5. Exactly same manner we can write, उसी तरह से हम क्या लिख सकते हैं इधर, 2m minus 1, 2m minus 3, 2m minus 5 up to so on. The last term will be 1, उसके पहले वाला टर्म क्या आएगा, 3 आएगा, उसके पहले वाला 5 आएगा, ठीक है, एंड ये रूट पाई तो रूट पाई है. सो दैट इम्प्लाइज आई कैन राइट हियर, ये तो सारे के सारे टर्म मल्टीप्लाई करके रखा है इधर, तो इसको मैं पहले से लिख सकता हूँ 1 इंटू 3 इंटू 5 ऐसे लिख सकता हूँ. तो 1 इंटू 3 इंटू 5 up to here 2m minus 1, sorry 2m minus 5, 2m minus 3 into 2m minus 1 will be equal to, ये रूट पाए इधर आएगा तो वो डिवाइड हो जाएगा, तो ये हो गया कितना, गामा m प्लस 1 by 2 into 2 to the power m divided by root pi. I think we have been proved it. Here you can see gamma m plus 1 by 2, 2 to the power m by root pi. Okay, so hence we proved it. Okay, Okay, now we are going to go for another simple question, question number 10. Okay, in question 10 it has been given that we have to evaluate gamma 3 into gamma 2.5 by gamma 5.5. It is a very simple question. This is I think 1 mark or 1.5 mark question. This question will be solved by using the first property and another property, that is your gamma half equal to root pi. So first I am going to write that we know that gamma n minus 1 equal to n gamma n, or we can say n factorial. This is your first property. Okay, first property of gamma function. And also we know gamma half equal to root pi. So to find the value of this question number 10, we have to first evaluate all the individual gammas whatever given in the question. First we are going to find out gamma 3. Gamma 3 can be written as gamma 2 plus 1. So by first property, whatever written over here, according to this value is nothing but your 2 factorial. Okay, then we are going to consider gamma 2.5. Here gamma 2.5 can be written as gamma 1 plus 1.5. ऐसे लिख देते हैं 1.5 plus 1, gamma 1.5 plus 1. So if I will apply the first property upon this, we can write 1.5 gamma 1.5. Okay, again 1.5 can be gamma 1.5 can be written as like this, 0.5 plus 1. So this will be equal to 1.5 into here 0.5 plus 1. According to first property, it is nothing but gamma 0.5. Gamma 0.5 is nothing but gamma half. Okay, so 1.5 into 0.5 into root pi. Gamma 0.5 is nothing but your gamma half. So gamma half, we know that root pi, right? Right. Now we are going to evaluate gamma 5.5. Gamma 5.5. So gamma 5.5, first it can be written as gamma 4.5 plus 1. Then 4.5 plus 1 can be written as 4.5 into gamma 4.5. Okay, then again it will be written as 4.5 into gamma 3.5 plus 1. So it will be 4.5 into 3.5 into gamma 3.5. Again 3.5 can be written as gamma 2.5 plus 1. 4.5 into 3.5 into gamma 2.5 plus 1 can be written as 2.5 into gamma 2.5. So 2.5 value already we have been evaluated here. Okay, so directly I can substitute this value, 4.5 into 3.5 into 2.5 into 1.5 into 0.5 into root pi, right? Finally, the answer of the question, given question number 3, will be gamma 3 into gamma 2.5 by gamma 5.5. So gamma 3 we found 2 factorial into here gamma 2.5 is your 1.5 into 0.5 into root pi whole divided by gamma 5.5 is your 4.5 into 3.5 into 2.5 into 1.5 into 0.5 into root pi. So here 1.5 0.5 root pi got cancelled. This is also got cancelled. And finally we got the answer that 2 factorial is your 2 and 4.5 into 3.5 into 2.5. If I am going to multiply, then it will be here you can see 4.5 into 3.5 into 2.5 will be equal to 39.375. So this will be 39.375 is your answer. Okay, so here I am going to stop the discussion of gamma function. In gamma function, we have been discussed uh, about gamma function, different forms of gamma function, properties of the gamma function, then numericals. Okay, different type of numericals we have been discussed here from question number 1 to question number 10. So in question number in 10 questions, I think I have been discussed in different type of all type of questions belongs to gamma function. From the next class onwards, we are going to start to discuss beta function. Thank you so much for watching this video. Thank you.